right? So like now we can use CP-31 should this make it beautiful. Right. So make it beautiful. An array is called ugly. Is called ugly. It contains at least one element which is equal to the sum of all elements. If the array is not ugly, it is beautiful. मतलब एक array दे रखा है इन्होंने जैसे ugly कह रहे हैं और it contains at least one element मतलब एक contain कर रहा है at least one element जो equal है sum of all elements. तो एग्जाम्पल दे रखा है इनके guys. Right. So example is 6396. So element 9 is equal to 6 plus 3. And the array 557 is ugly. The element 5. And the second one is equal to 5. And you are given an array such that 1 less than a1 and less than a2, and you have to yeah, and then reorder the elements. The resulting array is beautiful. Note that you are not allowed to insert new elements or arrays. Right. अच्छा तो इनपुट लाइन ये हो गया. अच्छा ये हो गया. An output for each test case. Print the answer as follows. अच्छा. If it is possible to reorder right, so we can also do input क्या क्या आ रहा है. अच्छा तो ये है इसका। तो यार इनपुट इनपुट ये दे रखा है यार इसने, है ना। अबे अगली है, अरे कॉल्ड अगली कह रहा, बट एटलीस्ट वन एलिमेंट इज इक्वल सम ऑफ ऑल एलिमेंट्स। अच्छा राइट। कि यार होगा कैसे, चलो मान लिया अगली है अभी। राइट बट इसका इतना कर दें, इतना कर रखा है। तो क्या है यार ये वन लेसन यूनिट इनपुट कितना दे रखा है इसने। ये दे रखा है रिएक्शन ड्रॉप करते हैं यार, देखते पहले। If the array is not ugly, it is beautiful. So for example, it is written that the array 63696 is ugly because you see the element 9 over here, right? So this is ugly. The 557 is ugly because the element 5 is equal to the first 5 that also the second 5 is equal to the sum of all element that fall before that is 5. So it's only 84104 because you can see if the compare this 8 then not equal 8 by individual and element, right? Range इसकी 100 है, right? Not inserted element हो जाएगा, the element of you are allowed to keep AR unchanged, right? So like this is like 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 n, hold on, medium element कर देता हूँ, and where a is equal to a, a1, a2 and a3, right? Like array you have a1, a1 and a3, a4. So now they have given you condition that these numbers are written like one, right? One less than a, a1 less than a2, so on, right? So on like uh, right. So even so they have something defined as ugly and beautiful. So let's try to generalize that part. Ugly and beautiful come from a simple definition. They have defined that if you pick up any number, let's say you pick up, let's say you pick up AI. If AI is not equal to the sum of numbers, the sum of numbers before, if I in this case I k1 a plus 2 है, if AI is not equal to these numbers, and this is true for all, right? Remember, true for all AIs, then you can say the array is beautiful, right? And if there is any signal AI signal, like any one a, the like array is called, you can say, this is called ugly. This is what they defined in the terminology beautiful and ugly. I hope this is clear now. What they were saying is given you, like you have this like AR reorder, right? It anyway you like, so what is the meaning when I say want to reorder? It means I cannot insert a new animals. No, you cannot. Existing element, let's say the number like a1, a2, a3, a4, then maybe I just do some changes, and maybe let's say I bring a4 at the end, right? Sorry, start then a2 and then a1, a3. So somewhere I have reordered the element, have changes the position element, but the elements are still the same, right? They are still a4, a1 to a4. They are come in a different order. So this is called reordering. So the is power reorder, and your reorder have you like this is allowed to you, and just tell me whether you can actually some reordering create an array that is beautiful or not. If you can, then what they have said go back in the question, then you simply need to know. But if it's possible to reorder in such a way that you can create array, then print, you will have to print order also. This is very different sort of question. Normally people ask like yes or no, normally question it asks you yes or no, but it is asking you if you think it's possible. But the yes case, it actually asking you to print the array. So if you print yes, then in second line you will print those an integer in the specific order for beautiful array obtained by reordering elements. You have multiple answers, that's why they are written any beautiful array. But that's not a concern. You are trying to find out one specific answer. You are feel you have beautiful array created. Alright. So this is whole question. If you can then again same thing print yes, and right, else you print no. Alright. So like you true to side test cases, right? Like whatever we have discussed, we have generalized how does apply to test cases. Okay, so you let's say the array 1 2 3 4 5, right? So over here they have said that the answer is yes. Why? Because they have said there is a rewarding. I will take this 1 2 3 4, right? So they are rewarding like 24153, right? Okay, so 24153. If you look over here very simply, then let's say I'm talking to about the first element. So first element is 2, right? And the 2, the element that fall before they are nothing. So basically, we treated them as 0. So the sum of element that fall before 2 is 0 and 2 equal to z. No, this is not true about the 4 elements. Sum of the elements of the number of the right plus 0, basically it's 2 only. You can, this 2 4 is not equal to element falling before one sum is 6, and that is 4 plus 2. Also not equal before 5, you have 1 plus 4 plus 2, that's 7. Also not equal, and before 3 you have 5 plus 1 plus 4 plus 2, not equal. So any AI, or if you pick any in this, you have calculated the sum of elements before the, but it doesn't happen, and that's why the this loading you have finally done is not beautiful. So I would have printed yes, and I would printed this order, right? One second, guys. What is this happening here? Right. So what is the rules? Like if the max and min of of array is something of the array is equal, or simply put put the whole array is having like same number of same number and the same number, some number, let's say x, right? Let x, then like answer is no, right? No, and the answer is yes, right? This is the whole argument. Let's read once more. If the max and min or minimum element, minimum maximum element or minimum in that is equal, or indirectly if you try to picturize this, if the minimum and maximum in the array is equal, that means whole array is having only one number, right? That some number random x, then the answer is no, else the answer is yes, right? Let's try to see why. Okay, so of course let's try to understand this yes case, right? If you have, let's say, the array a1, a2, a3, a4, so on a5, right? Till now, of course, in this array there is going to be a maximum element, right? Of course, in there is maximum element. Why I am bothering myself with this maximum element, we will try to understand within the next few minutes. But catch up with me. I have maximum element in the ads in the as, like, so maximum element is a5. Now you want to reordering, and you of course want the AI fulfills the condition that it doesn't match in total quantity with the sum of elements, right? That fall before it. Now listen to this idea very carefully. If you pick up this maximum element, that is a5, let's say I bring it at the front array I, so reordering is possible. So I will bring a5 in the front clear. Now if I bring a5 in the font, right, I have lots of advantage. I think a5 is a very large number, right? The largest number in that manner, it's very large. Now since it is largest number, let's say I have the numbers ai, a2, a4, any other. So until I fall in other, it, it is very advantageous. So as we move, I've done right now, pressing lightly over here. Let's say you talk about, right, like, it's like, let's say you talk about element a2, a2, of course let's say a2 element, a2 element of course is less than equal to a5, right? So yes, a2 of course is less than or equal to a5, because we know very simply that a5 is the largest element. This is the max. So a2 of course is less than or equal to less than equal to 5. Similarly a3 of course is less than or equal to a5. Similarly a4 will be less than or equal to a5, and so on. I will come to a1 also. Why I am not mentioning a1 is because of a very simple point, but bear with me. We know that numbers from a2 to an, they are of course less than or equal to a5. If you consider any of these number as your current ai, let's say ai pick up the ai to be some number, let's say a3, then for this a3 number the sum of elements I am looking at is like till this location. All right, now very simple put that less than equal to a5, it could have been equal to a5 and have been equal to a5, but now we are not checking a3 with a5, are checking a3 with some of the other element that fall before it, before the number that falls are of course a5. On the top of that you have also some more numbers with fall 8. So can I guarantee say that for a3 numbers before it will create a sum that is greater than a3, or to be simplified, put not at all to a3. Why? Because a5 itself was creating a boundary that was like, if the sum was simply a5, it was still greater than equal. And now that you have been added on a1 a2 also, boundary has to, of course, so go greater not equal anymore, so this is equality is removed. And you know A3 will never match the sum of elements before it. Now try to see, even if you take 80, it mightly currently so be less than equal to A5, but as soon as A5 adds it's a positive here 100. So since very integer is positive, I know that adding some number on top A5 will make the cumulative sum, right, greater than A2. And this equality A2 will so satisfy the condition that is not equal to the sum of element that fall before it. So by putting A5 with the assume maximum element, right? So started I have created such a condition that it's A2, A3, A5. So on sorry A2, A3, A4, so on A till A6. So take last element, and however I put them, I'm not bothered like in this case I just showed you putting them strictly in order, but however you reorder them, you know, I simply visualized mathematics that the cumulative sum before it will never be equal to be very specific cumulative sum before it will automatically. So go greater because I have genuinely put such a large number in the front that cumulative it's giving me very large numbers is always going greater than the current. All right, I hope it should be clear now, right? but but here is, let's say I write this condition a1, of course in the start is less than a5. Now if you bothered yourself with a1, the sum of elements that fall before a1 are only a5. Observe very carefully. For a2 you had some a5 plus something, right? For a3, so you add some a5 plus something. For a4 you add the like a5 plus something, which we observe over there, these blue blues, right? Perspective, the number some falling before it only consists a5, that is right. So like I think it is done. Okay. So you like using a sublime text, right? Don't. Right. Like so like चेंजिंग कर देंगे। And then long and so like number of elements. And then long and right. So this is like your array to store the elements. Like two inputs are now right. Dot plus and then sort the array in decreasing order, and then long x is number minus 1 right. Insertion number is equal to 0. Just number. So like check if the elements are the same, right? Count. Right. If all the elements are the same, it's impossible to make it beautiful, right? Right. So count and it is possible to the order to make it beautiful, right? So count to start with the maximum element. So it is equal to 0 greater than n minus 1 I plus plus. So print the rest of the elements, right? Right. Then count end of the current test cases and then like turn 0 कर देंगे. Like time, what was the time complexity? Time complexity is like big O log n plus big O n. So big O log n हो जाएगा 50 that into log to BO 300 हो जाएगा, right? And space on the BO is n is like 50. Like to copy this code. Like to submit. I think this will like to accept it. Right, I think this will gonna accept. I don't think any like so accepted, right? Now this is accepted. So refresh करते हैं साइड पहले तो. Now this will question. Everybody likes a tree, right? Right. Don't think why this question, why my net is right. Oh, this is work. Hold on, guys. So like right, like everybody likes a good array. Okay. So an array is good if all pairs of adjacent element, that is AI, and then AI plus 1 from I less than equal greater than or equal to 1 less than and right, different parity. Alright, so we will understand what does the term mean. Note that an array of size 1 is trivially good. Okay, trivially good. Now you are given an array of size n and you can select any pair of adjacent elements in which both elements are of same parity. So you are to insert their product in the same position, right? And the minimum number of position. Right. So guys, like my background noise, why it's right. So like alright, we have to read the problem. Let's try to generalize what they are asking. Right. So I will do set the canvas. Firstly, like how see now I done. So I said over here that right, like a is equal to a1, a2, a3, and this a4. So now like a1, a2, a3, right, a4. So dot till I have the numbers, like you write to so on, like an, right. So if here they are saying that array to be good, and this array to be good means every adjacent element pair that is that I can mark with this mark with like right. So a4, hold on guys, right. So like parity, right. Parity is like, sorry guys for this, right. Parity is like add and even is add and even number is odd. If let's say number is even, whatever nature it contains with respect to this odd and even nature, right, it's basically called the parity of that number. So now coming back to the problem, if I say that I want adjacent elements to have different property, that means for example, let's say I take up these two pairs, right, like a a1, so a2, right, these two numbers as a pair a1 a2, then if let's say assume that a1, right, if a1 is like odd, right, odd nature, and the a2 is like even, right, a1 is like, right, hold on guys, even, right. So then we would like to even property. A1 had an even property, then a2 will have an odd property. Hold on, like, so we after like even and odd, right, So both cannot have the same parity. This is both cannot be odd, or both cannot be even. All right. So very simple. Parity is again the general representation, right? Idea. When we when we talk about the nature of any number with respect to its odd and even property, and that parity that is termed in our coding language, right? We actually term that the thing, like we using the parity concept in this problem. So what they are saying is we want different parity of the adjacent elements, right? So I repeated again, a1 a2, it lets you have one as odd and one as even, right? So one as even, one as odd, both cannot be odd and both cannot be even, right? So these are different parity. That's basic common sense, all right. So now we want the whole array to be good. Okay, now what's given to us? Okay, this is like this array has to become good. It's not initially good to make it good. You have been given an operation to perform, like operation you can actually do, and this operation what it does, it state is right. If you select some pair of existent elements, it in which both elements have the same parity. For example, I just selected ai plus 1, right? So let's just search one element ai, and let's say the next element it came to a plus 1. Then if let's say their parity are same, right? So that if let's say both are even, right? So let's say ये भी even है, ये भी even है, right? So this happened to the same parity, then you can delete them and then insert their product in the same position, all right? So if let's say I have an array generalized, let's say a1, right? a1 a2, hold on, a1 a2 a3 a4, right? So like hold on, like this a1 a1 a2, right? a1 and like suppose no, like right, like to a2 a3 लेते हैं ना, a2 a3, right? a2, right? That's both of them were odd. And then what I can do this is like I can take a a1 can take a4 and then place a4 and of a2 a3 delete, and I can place their product that a2 is into a3 as a singular element over here, right? It, over here this is one operation doing this, and this is one operation, right? Okay, and then doing this is one operation. I hope this is clear. Now what they are saying is by using this operation, tell me what is the minimum number of operation you can do, right? You can do to make your array get good. That is finally every adjacent elements pair is having having a different having different parity. That operation count, I can call this, let's say, minimum operation, right? Let like minimum operation, right? Minimum operation, this is something that we want print or that we want calculate. So this is the whole problem. Now let's say we have to some test cases, right? So over here, all right. So let's just say there you have a test case like 1711, right? Right, like 1711 and 2 and 13, right? So very clearly, this is odd nature. This is odd nature. This is even nature, right? So like, so this is odd. This is also odd, right? This is also odd, and this 2 is even, and this 13 is odd nature, right? So what can I do is I can do something like this. Let like elements of odd nature, same parity. Let's multiply them and insert them back. So deleted 1 and 7, even multiplied 1 and 7. So you got a 7 and you inserted 7, 7, 11 to 13, right? So like this is odd, this is odd, this even, and this is odd, right? And so, and this both of them are odd, have the same parity, right? So multiply them and insert back their product after deleting them. So I have something that looks like 7 and 7 and 2 and 13. So this is odd and this is even, this is odd. If you take up any adjacent element in this, let's say you take up these two elements, or let's say you take up these two elements, I say that they have different parity nature, right? Of course one is, let's say, one over here, let's say odd, and then other is even, right? And then if let's say you talk about the other pair, one is even and one is odd, so you are good to go. Can you term this is as, I can turn is good array, right? Like can turn a good array, right? So consider how many operations did you do. We do one operation to combine 1 and 7, and then we did one more operation to combine 7 and 11. So you did two operation total, and this becomes answer. So the sample output was like, so it very easy to understand, but we try to picturize what we are trying to do, right? So now you, if you pick your pen and paper and like you can pause the video then, and you will able to figure the rest of two cases. I am not doing that, right? So let's moving ahead. About now very important idea before actually deep diving into main solution, right? Like if you want to create a solution initially, like what is what, like टाइम कॉम्प्लेक्सिटी like B को बना है N भी हो सकता है, right? So I'm looking at, I know like I can start with some like some problem discussion in my head, like maybe I can fetch up a good solution, maybe and B1 maybe like n square, right? So I will go to go right. Let us my initial idea is like to approach like first of all we when we talk about parity over here, we have to understand we have very important thing like I am deleting them and I am start inserting them, right? Then back, it's a very variable question to ask that if you start off these two elements, let's say I have these elements like E1, E2, you basically delete them assuming like both they have the same parity, right? Right, same parity is like E3, right? The sample case over here, once I'm deleted the like 1 and 7, asked myself again that the new number parity was it even that we have done it previously, right? So like I asked this to myself, now I don't want to simulate this process, right? So finally submit the main problem, meaning like we know by the fact we can write this down, right? We can write this down over here. If I like E and E2, one side guys, E1 and E2 both are odd nature. So let's take an example. Let's say E1 and E2 both have an odd nature. That means they are of this format 2, like here to like 2k plus वह यार ये क्या था क्या 2k plus 1, right, into 2k like 2k2 plus 1, right? So whole number in the range of integer line like 2k plus 1, 2k plus 1 is the general representation of an odd number, right? Like I have taken for E1, it's 2k and 2k1 plus 1, right? And you can write it to 2k2 plus 1. So now if you multiply these two, that is the product that I am talking. If you do that, you basically get something that look like 4k1 and k2 plus this is like 2k1 plus this 2k2, right? So like you can like 4k1 k2, right, plus 2k plus 2k2 plus 1, right? So this one, now a very important point of this number, that is basically element 3 is this a number is still odd, right? Why? Because if you multiply, if let's say I want, if I want to divide, sorry, this by 2, right, this by 2, right, this way, so we will distribute over there, but this plus 1 is being a problem, right? This is going to like 2 divided by 2, 2, right? This is cut, right? So to make the parity of the A3, but actually as or what does that tell me by general mathematics, right? So just tell me that this number is still odd, right? This number is still odd, right? Odd into odd gives me an odd number, right? This is case number 1.1 point number 1. Now even going further on this part, case number 2 would be if let's say like E1 is equal to E2, both are the same, both were even, so same general, let's okay, even was our nature 2k1, that's basic. 2k1 is the general representation of an even number, and then you have multiplied as 2k, like I'm saying I have like 2k1, right? 2k2, right? So like 4k1 k2, right? And is not this number divisible by 2? Of course, if you write this number, so like divided by 2, right, which means this is fully divisible by 2. That means this new number A3, which would have gotten even, this is actually even, so this tells me that even into, right, like is even into even is also even, right? So why was this even useful, right? Let's go back and think. Why useful the so very importantly, over initial the array is not good, right? So let us, if an array is good, right, what should it look like? If you say like this is an, if you say that your AR is good effectively, it should like either these two cases. This is case number 1. If you want adjacent parties everywhere, like this is basically you're trying to alternate the party parities, so the array would look something like this: odd, even number, well, even number and odd number, right? So like odd, even, odd, even, odd, right?
So can look this case in write even number, odd number, like so then like even, odd, even, odd, even, odd, right? So are the two variable cases where actually termed that to be good. It's common sense, right? Try to understand if you are talking about every two adjacent element, so having the different parity, that means if let's say you started off with the start first two element having the different parity odd and even, the next two elements parity, as the third element should have the parity odd, because then if you take these two elements for even and odd, it will not fulfill the condition. If this is not odd, this is of even nature, right? So makes sense. And and the whole idea of propagating even and odd, this is going to go the very end of the array, which would basically mean that good array by definition, so it's actually an array which has a alternating even odd parities, right? So either you have case number one, right, and where you start off an odd and then you go odd even, right? So odd even, or you start off with an even and you go add an even odd even. These are the only cases, right? So but the catch over here is your initially array is not good. What it might look like let's try to understand. For example, like the array initial, this is case 1, right? So like this is case 1, hold on, this is case 1, right? And this is case 2, right? Or any case, actually initial condition like array might look somewhere like it might be having like 0, like odd or 0 कह रहा हूँ, and even, right? There's some more odd elements like odd elements, odd even, right? Let's say an even element. So this is just an example, right? I have just noted down that even and odd nature of the array. This is what my array initially will look like. All right, so we want this array goes for from this to look something like a here. Now observe over here, this very crudely we want, right? So odd events, right? Odd event alternate if I wanted my operation to be executed, I can only take adjacent elements, right, which which have the same parity, right? Over here the same parity elements adjacent, like this odd, like, so this is like adjacent and have the same parity, fine. But this is adjacent, like this is have the same, okay, great. Does these two element is being adjacent but have the same parity, right? And this like this or even have the same, no, this is not possible, because focus once over here, these two elements are these like are adjacent, like odd, right? So they have the same odd or nature, right? So we go back to our property 1. If we go like, right, if we like, so I'm not talking about the case where I go into this value. Just assume that there are odd numbers in a line. So what you can effectively do, I can say that I would have taken these odd numbers multiplied like them, multiplied them and one more odd numbers effectively, which would have made the more odd numbers, right. So go down and two numbers. I would have taken these two odd numbers, multiplied them, and effectively, right? So again gotten an odd number. So now, like this, this is like right. So odd numbers, and this is like also odd numbers. So now same idea. With two even number, multiply them, get back an even, right? And even take these two odds adjacents. So get back an odd, right? So write it only one even and not an issue, cannot do anything, right? So one even, take these three odd numbers, right? So effectively you would do two operations and make a single odd numbers out of them, right? So this is finally even, this can be copied, and as it is you have an even, right? So now look at the final case of the array, right? So odd even odd, and you do not get a case that looks in like in one, right? So something like this, yes. So effectively, like why did I identify if I have a segment of same parity of element, right? if I have a if I have like a segment, I will write this on a new page, right? Like if I have if if I if I have segment of element अरे यार meant of same parity, right? Of same parity, then I want to reduce them, right? Then I'll to reduce them to a single number. So let's say this segment length is s. Then basically you can say like y as minus 1, right? So like behind this, understand, once you more have some elements, you have some even, then some odd, then some even, so then some odd, like effectively, right? So like I want alternate odd even odd, or if effectively, right? If you want like alternate even odd even or even, so you want a segment of odd elements to finally club itself, right, together to a single odd elements, singular elements. You want a segment even elements club itself together to a even single elements, right? So to do, we would like to code, right? Like right. So now we can do a code, right? Like then we would like to so like यार अगर हम इसको कोड करें है ना, चल इंट में आ जाएगा एंटिटी then 4/long I is equal to 0, right? And right, so this is loop to input elements into the array, right? And then like send I, right? So like input complete, right? And then long operations count is equal to 0. Like first I initialize the count of operation to 0, right? And then we like to loop through the array to check adjustment events. So for long I is equal to 0, I greater than n plus 1, I plus plus, right? So check, you like to check if the current element and the next element have the same parity, right? So we will write if so then like two operations, right? Then they like increment the operation count if they have the same parity, right? And then they like to what was going on here? Return 0. ये क्या हो रहा भाई? Right. So like to submit the code, right? Yeah, नहीं अभी तक यार. No, it doesn't. same with the code. No, I think they are right. This is accept. Done. 2 question right. Right. Then refresh it. So now, how much है question 827 कर लिए. 4 is waiting to go. Okay. Right, so we can do extremely array. Extremely long. Sorry guys. Right. Then this one, I think. So extremely round, like let's call a positive integer extremely round, right? If it has only 1 0 digit. Okay. So for example, 5004, 110, 2000 are extremely round integers, right? 42, 13, 66. Not इंटीजर दे रखा है 1 से लेकर 10 रेज़ की पावर 4 तक. अच्छा, चाहिए दे. तो उसका ये हो गया. करना कैसे है ये देखना है. एक पॉजिटिव इंटीजर दे रखा है जो एक्सट्रीमली राउंड है, राइट? सो इफ इट हैज़ ओनली like only non-zero integer and right extremely large integer such that x is within the range 1 to n. So basically our 1 to n I need an all extremely round integer दे रखा है. So it's very simple and what है right? So now like here, are extremely round integers and that they have which have only one non-zero digit, right? Those are called as like extremely round. Extremely round, yaar. I mean non-zero. That mean not zero, right? Like 1, 2, 3, 4, 5, 6, 7. These are odd digits. They are non-zero. Now in a number, that means you need like this. Say one non-zero digit is 6, and then result like 6,000. So like even non-zero, right? Just go here. See round integer तो है, but given example दे रखा है. इसका अलग अलग है. Only one have non-zero, right? मैं यार 44 है. 500. And they're coming 66 will they have, so as these are not extremely round integers, right? Like 66. So what they are saying is given the value of n to u, and you have to print all the count of extremely right round of integers. So let's call this count. Let's let the count between 1 2 and inclusive, right? Like 1 2 and then inclusive, right? I have to understand generalized of what the question is saying. Let's quickly look into some the sample case. All right, so very simple test case है. Let's you have been 9, and what would happen to if I report n to 9? Like n is equal to 9 ले लिया, right? And then basically any number from 1 to 3, right? Like 1 2 3 4 5 6 7 8 9 to be judged. Now the cases is very number, is actually an extremely round integer, because you only have non-zero digits. So the answer is quickly simply turns as right. So answer is equal to 9, right? So like these have 4 cases, right? So what are they trying to picture me about, like me or you, like there's something. So you got all right, great. So now let us move to on a very important thing, that is accepted time complexity. अब accepted time complexity में जाएंगे यार. Beginner problem I try to general, and I think of an ideation of how will I go about this problem. How about I first get to know what's the expected time complexity, right, from me, so that's it makes a better sense. So I create a solution. I know that it should not give me a right. So all right. So by the fact I know I have know the few things, like 1 second is like 10 raised to power 8, right? So elementary, now it is given the time limit per test is 30 seconds. So I'm talking about like one test case is like 3 seconds, right? Is equal to like 3 into 10 raised to power 8 to do for each test. Now every test will have some test cases, and test cases are t, which are given in the 10 की power 4 order, which means if I ask you what is the number of elementary operations, right? So you are allowed to for every test cases, like then your answer would be like, 3 into 10 raised to power 8, right? That is for one test. Upon 10 raised to power, right? So 3 into 10 की power 10 की power 4, right? So how this will help me if you look over here, 9 as in 9 6 into 9 order है, which means like n is equal to 9, right? So equal to 10 raised to 6, right? 6, right? So like if like plus 1, then right, eventually touching it, like you can say, right, 10 raised to power correct. Now if that is the like case, that this tells me that if, let's say, I even write a solution, right? So un into un b1 means 10 raised to power 6 operation, and you have been allowed for each and every test case 10 raised to power 4. So you can actually try this and you will get it. This that means a BO of a solution doesn't work. So we need to go even lower, right? So log, log base 2n, right? Log base 2n, right? Log log is 2. So maybe if you are able to constant time complexity, that also works. So bigger one like constant, right? So what tell us that if I would have created an idea that is running in zero, so and I could have normally stopped over here, and this is what normally beginners, right? So could have committed as a mistake that could have not. They would have created a direct or big one solution, which is very directly visible, right? So expected time complexity तो ये हो जाएगा bigger one, right? bigger log 2 नहीं हो सकता, but ये नहीं हो सकता bigger one, right? So my time complexity, like I do not want to create a solution that look like, right? So alright, great. So now how do we create the solution if like big of n is not allowed? What the problem over here, right? Is normally problem don't go below big of n in this rating. Correct is like we don't. So normally big of n ही होगा यार, इतना क्या सोचना है इसमें. अब वो देखते हैं अप्रोच कैसा शुरू करेंगे, राइट? पहले कहाँ तक पहुँचे? राइट. सो लाइक अगर हम ब्रूट फोर्स जाए, so like for 2 minutes that we know expected time complexity, right? So one, like how would I first discuss the solution of big of n, and then let's see what are we trying to finally achieve and can we optimize. If I ask you in a very single goal, like what would have been your direct approach in the problem, right? So you would have been a very clear. How if it, let's say I have been given a number and and n is like n is very high and it is the highest number is 9, right? So 999, and tell me to check whether this number is extremely rounded or not. So this solution or the function I would have created to do this, how much time complexity would have it utilized, right? So very low. Why very low? Because all you would have needed to is go on every digit of this number and just to make sure that eventually the count of non-zero of digit is like 1, right? And to do maximum you would be doing 6 iteration on the digits, right? Because that's the maximum size So can I say that the function, whatever the function I can create, right? So like whatever the function I create, bigger 6 which is approximately, writing this is approximately constant, very quick, it constant, very. So now the question comes that if to check whether the number is by broad solution, and that's directly I would just like to go on the last and the second iteration, go like how in big formula, if that is very constant, it's kind of saying that it's basically bigger of time complexity, right? Why could I have not just done a simple for loop for every test cases? So I could have done a for loop test, ran a loop from one for like for one one to and was an integer is I, or better. If this is an integer, let's say x, then all I could have been done inside of for my loop, right? So I could have called this function pass x inside this, right? So function x, for if this, I could have been incremented my count by 1. That's all I could have done, right? Now, so now I would have approximately time complexity like big of 6, and this function would have been run. So, into 6, right? Big O N. So we know that big O n would have normally worked, but the problem over here, just now n is a solution that 10 parts 6, sorry, and 10 6 doesn't work because I have been allowed 10 powers 4 only. That means I needed to think even better than this. Alright. So now this is a very new idea that comes into this problem, right? So it's something that has been not explored previously. For me, I've not explored, right? So this is called pre-computations. Alright. So let's explore this idea. What is the physical meaning? This so like physical meaning of the right? So pre-computations as a word stated simply by English. In English meaning it means that before actually doing your main competitions, right? So main like solution to the answer, calculating the main solution to the answer. So how about you pre-compute, right? Pre-compute some data which helps you compute the latter proposed solutions. That's the physical meaning of pre-computations in CP, right? Or in generally when we are talking about this language, all right. So so how what is the free computation that we can do right now in the problem, right? So like how's the introduction come to my head and how will that help? Let's discuss that part. So the point is, first of all, you are trying to the answer the count of extremely round integers, right? And from 1 to n, 1 to n. Now the constant question is, you are the you are always trying to answer, you are always trying to answer whether you have a extremely rounded, right, rounded integers, and to a certain limit. Now this question you are answering, but explore the first test case and then the second test case, the question changes. Then question always remains count the number of extremely round integers, right? The same every test case. Now if let's say I have the first test case first, right? So just assume that, and let's say in the test case like 500, right? 500 extremely round integer, like you could have been gone through 500, and 500 turned out to be an extremely rounded integer. If you go on the second test case, and let's say in the also you encountered, right, like 500, sorry guys, 500, so it will change when an x round integer. So you can see that you are kind of bluntly asking my function again whether 500 was an extremely round integer, right? So how about if I could have somewhere pre-computed whether 500 was an extremely round integer or not? Will I have to ask in every test case again, right? So again and again, whether where 500 was an extremely round integers, no, right? I will save time, complexity, smart, all right. So that is the idea whether I get my institution because of the fact, right? Answer does not change when it comes to asking whether a number x is x is an extreme round integer or not. About before we actually going in the loop of my test case, that is the I could have a return while you are minus like, so you will like to loop, right? So how about even where the pre-computation, that somewhere here I use my extra line of code to actually pre-compute certain limit, right, of extremely round integers, which can be well notified the fact, right? So n of going maximum in 9 order of. So how about before starting my piece of code, maybe what I can do is simply in a vector, in a data structure of vector, right? So I can run a for loop from 1 to n, right? 1 to, like, for, like, here I go to a vector for 1 to 1 to and for 1 to and 9, right? 1 to n can be taken out, and this x variable can be simple asked with that function whether it was an extremely round variable or not extremely round number. So or not, if if it was that, what can I can do is can simply insert inside the vector. Let's call the vector something like vector. I can just push back inside the vector as a variable, right? So x push back, right? So push back something like small, right? Here we go. I like to do like, if we do pushback like something like a small and x, and then if we now observe the time complexity, what we can our solution comes up to be, if you observe the time complexity up till this, here will time complexity will be simple into big O and into 6 of outer loop, right? And to 6 would the appropriately the higher bound on how do we calculate every number to of extremely round nature, right? And then if now we go in test cases part, now inside this, like inside this, where like okay, run loop from 1 to n, that's fine. But when you run a loop from 1 to n, you would have achieved a time complexity, right? That goes in of an order. Since I don't want to, how about I do the other way around, can be simply inside this v loop. So what I can do is I can iterate like, hold on guys, like for a like, I can just check whether the number like num c is equal to n, right or not. If it doesn't, then I can simply does a counter, right? Plus plus. Now this sort of simple iteration on the array, but not rather than on, saves a lot of time complexity. Why? Very important to understand that that extremely round integers is going to have a sparse nature, correct? So they are not going to have a very sparse nature, right? Sparse, that is extremely round integers, so they are not going to be a very high numbers. When you go to when you go to then why was the property of the extremely round integers is such that the property is very specific. The property, right, is you need only single non-zero digit. Now in a single non-zero digit, you cannot take a lot of numbers into consideration, right? That means this array, this arrow, because we do not want to the right calculate mathematically how many, but I know for a short by intuition, right? For a short intuition is going to have a size much lower than 10 or part 6 order, right? And definitely much lower than you can say 10 power 4 order. That was actually that accepted time complexity. So we could have achieved, right? We could achieve. So what we discussed over here, that we want something like a 10 power 4. So I know that we will have much lower 10 power 4 x around integer. Yes, same this array. So now if I run this logic instead of directly iterating from 1 to n, so I would have something that looks like you will write this big of 10 raised to power 4. So alright, so now of course not approximately, this is exactly 10 raised to power 4. So we can obviously see later in a piece code I will actually show what is that the exact time complexity in which we are running for every test case, right? So this that is basically depending on the size of the array. I'm just approximating this is to be higher 10 raised power 4 because that is what we wanted for each and every test case. So every test case time complexity run in 10 raised power 4. Now if you ask me the total time complexity, how did I write that? We are right. we go into 10 n की power 5 6, right? The equivalent 9 into 6, right? Into 7, and please, when 10 raised to power is for each and every test case inside the wheel loop, how many test cases you can 10 raised to power 4? You can multiply to say 10 raised to power 8. Yeah, 10 raised to power. So in order 10 raised to power 8 for every test, remember we are allowed something like 3 into 10 raised to power 8. So isn't this going to work? Yes, of course, this is going to work, because all for every test cases you have finally achieved dyne complexity that trans 108, right? Remember, now we are talking about you have clubbed the pre-competition time and complexity also. So now a dependency coming for every test cases like 3 into 10 raised to the power 8. So this definitely work. Now for this going to be much lower, so we will actually come to the code and see, but this is main behind the pre-competition, very important for beginners, right? Should definitely note this down, because this is what helps us solve an even higher rated problems where we have actually like strongly pre-compete while looping part, and this will only come into action once you practice the expected time complexity. So you need beforehand. Okay, so where I could have stopped and what do I have what to pre-compute, the idea is going to hit automatically, right? So simple brute solution of pre-computing how every number looks extremely round push into a vector, then rather than going to big O and so go to that vector and check whether that was less than or equal to n. Now if it is in the vector, then an extremely the range of 1 to on add your counter. So this is this sort of general calculation of the all the time complexity moves on big O and to code to understand what is the exact time complexity, right? So we can actually figure out how many right. So like, so we are going to do code, right? Now we can so now we can do a code, right? इसका तो अलग होएगा यार. यूजिंग नेम से हिस्ट्री तो हो गया. Like function to check if a number is number is extremely round, right? So what we can do, boolean check long x, right? So the maximum x can be, right? And then to count total digits in X, right? So we'll write now count slash of this digits equal to 0, right? To count total digits in X, and then we to count number of zeros in X, right? So long count slash of zeros count number, right? So while x like this is like loop through each digit is x, right? X percentage 10 is equal to 0, right? Now check if the current digit is 0, right? And then count as of as 0 plus minus, right? This is increment 0 count, right? And then count plus so increment digit count, so x divided equal 10. बड़ी जल्दी. So remove the last digit from x. Remove the last digit counts. Like return true if all digits except 1 are 0. Return count return count of zeros. Digits. This one, right? So ये like time complexity को 6 हो जाएगी क्योंकि since maximum 6 digits है, right? And main and like all the extremely round numbers to 999. So like vector long right to round and numbers. to right, like this is like loop through all numbers from 1 to 9 raised to the power 6, right? So like if check I is equal to true, right? So like check if the number is extremely round, right? Then like round slash numbers dot push slash back I, right? And then like entity कर देंगे because number of test cases का है, then then t, right? And while t minus, right? The process of each test case is right. And then like long and right and right and long answer equal to 0, right? To store the count of extremely round numbers less than equal to n, right? Then we would like to loop चलाएंगे 4 slash int I is equal to 0, right? I is equal to round slash numbers dot size, right? Then I plus plus, right? Plus round slash numbers I is equal to, and like check if the if the number is within the limit or not, right? And then like to answer plus 1, right? Then like to else break, right? To stop if the round number n exceeds, right? Right. So ब्रेक तो कर दिया इसके बाद, राइट? ब्रेक कर दिया इसे, काउट हो जाएगा आंसर एंड राइट आउटपुट द रिजल्ट फॉर द करंट टेस्ट केसेस, रिटर्न 0 हो जाएगा. लाइव टू सबमिट कर देते हैं. Time of life is go right. So now this is accepted, right? लास्ट कुछ नहीं है यार, वो कल ही करेंगे. So how are you doing tomorrow?